Alright guys, so today we are going to talk about the seasons on Earth. I'm going to give you a little bit of a more broken down, detailed version of this than you saw yesterday. So click through it, pause it where you need to, fill out your note sheet. Looks like this. And then once you're finished, go back to Schoology and work on the videos that I posted, as well as the seasons check-in that you have to complete and get at least a 90% on to move on. Alright, so the seasons on Earth, what causes the seasons? And we talked about this yesterday. Basically, it's how the sunlight hits the Earth. So sunlight hits the Earth's surface most directly on the equator. Near the poles, sunlight arrives at a more steep angle, and as a result, it is spread out over a greater area. There's going to be a few videos that I can show you here in a little bit that's going to talk about how sunlight hits the Earth and when it's more direct. So for example, if you're standing outside and it's noon in June and the sun is really, really high overhead, it's a lot hotter, the sun feels a lot hotter than it would at sunset or at sunrise when the angle of the sun is really, really low. So if you think about it, if you were to shine the sun directly overhead, it's much, much hotter and more direct than it is when it is when it's at a steeper angle, like at sunrise or sunset. And then at the poles, sunlight pretty much always arrives at a steep angle, and as a result, it's spread out over a greater area. So at the equator, we get the majority of the direct sunlight pretty much all year round. It's very, very direct most of the time. At the poles, it's almost always at a very steep angle, and as a result, it's spread out over a greater area. All right, the Earth's seasons. So the hemisphere that's tilted towards the sun gets more direct light rays from the sun, and the opposite hemisphere gets less direct sunlight. So for example, in this diagram, right now the sun's rays are striking more directly south of the equator. So here's our equator. It strikes more directly south of the equator, actually 23.5 degrees south, gets the sun directly overhead here, and the northern hemisphere where we live is getting less direct rays of sun. So this would be winter in the northern hemisphere and then summer in the southern hemisphere. So we have opposite seasons. So Earth's tilted axis. If Earth's axis were straight up and down relative to its orbit, so if it was orbiting like straight up and down, just orbiting around that, temperatures would remain pretty much the same all year round. So it would be like having some spring or fall all the time. But Earth has seasons because its axis is tilted a little bit as it revolves around the sun. So let me move this here. So the axis, like I showed you guys yesterday, is the imaginary line that is through the North Pole down to the South Pole, and it's tilted a little bit. So if it was straight up and down, it would be like this, but instead it's like this. So that means that sometimes the northern hemisphere gets really direct sunlight if the sunlight's over here, and other times it gets less direct sunlight. The change in seasons is not caused by changes in Earth's distance from the sun. So we are in an elliptical orbit, but that is not what causes the seasons. So in June, the north end of the Earth's axis is tilted towards the sun. So here's the Earth's axis here, and here's the sun off this way. You can kind of see that the Earth is sort of pointed, the North Pole is sort of pointed towards the sun, which means that the most direct sunlight is pointing at actually 23.5 degrees north. So here's our equator, and 23.5 degrees north is getting the most direct sunlight. So if you were to be directly, if you were to be in this position at 23.5 degrees north, at noon the sun would be directly overhead. And then we're kind of a little bit further up here, so we are getting pretty direct sunlight, but it's not fully direct. And then the southern hemisphere is tilted away from the sun. They're not getting as direct sunlight, so it's going to be winter there. And an interesting thing to look at is that in the North Pole, so actually above 66 degrees north here, notice as the Earth rotates around, it never actually is going to rotate into or out of darkness. So at the North Pole in June, when it's summer, they actually get about 6 months of total darkness in the northern hemisphere, in the North Pole, so above 66 degrees north. And then if you notice the South Pole here, as the Earth rotates around, it actually would never get any daylight. So during winter, the poles actually are going to get 24 hours of darkness. Gonna make it super hard to get up in the morning and go to work or school. So in June, the northern hemisphere, the noon sun is high in the sky and there are more hours to daylight than darkness. The combination of direct rays and more hours of sunlight heats the surface more in June than at any other time of the year, so this is summer. So combined with more direct sunlight, and because like in the last slide, when the Earth orbit rotates around on its axis, so this is kind of where we are, in one 24-hour day, we have a lot more sunlight than we do darkness. So combined with more direct light and more hours of sunlight, it gets hotter in summer. So Earth in December, the sun's rays in the northern hemisphere are more slanted and there are fewer hours of daylight. This is winter. So here is us, again, here's the northern hemisphere tilted away. So notice now the North Pole is getting 24 hours of darkness. The South Pole is getting 24 hours of daylight in December. The sunlight is hitting most directly 23.5 degrees south of the equator, which is right here. And we are tilted away, getting less direct sunlight, so it is winter, and we have a lot more hours of, so here's up by where we are, a lot more hours of darkness than we do of daylight, so that is winter. Okay. Sorry, I have to keep moving this thing around. All right, so in our orbit here, this is summer in the northern hemisphere, so we are tilted towards the sun. Notice the North Pole is kind of tilted, kind of pointed towards the sun. The South Pole is kind of tilted away. So this is summer in the northern hemisphere. Winter in the northern hemisphere is around about 6 months later in the orbit. Now we're pointed away from the sun, and the southern hemisphere is tilted towards the sun. Our solstices. So the sun reaches its greatest distance north or south of the equator twice each year. When the sun is furthest north or south of the equator, it is known as a solstice. So actually it strikes furthest north at 23.5 degrees north and furthest south at 23.5 degrees south of the equator. So the summer solstice is what we call those days, are June 20th to 22nd. Kind of depends on, if it's a leap year or whatever. And then the winter solstice, when the sun reaches its most southerly point on the Earth, is December 21st or 22nd. So summer solstice is our summer, winter solstice is December. And if we were in the southern hemisphere, these 2 days would be switched. So winter solstice would be June, summer solstice would be in December. But for us, summer is June, winter is December. The equinoxes, so the equinoxes are equinoxes are halfway between the solstices, so neither hemisphere is tilted towards or away from the sun. What this means is the equator is actually getting the most direct sunlight. This occurs twice each year when the noon sun is directly overhead at the equator. So instead of being directly overhead north or south of the equator, during the equinoxes it's directly overhead at the equator. Equinox means equal night. So during the equinoxes, everywhere on Earth gets the exact same amount of daylight and darkness. During an equinox, day and night are each about 12 hours long everywhere on Earth. A vernal equinox is spring, March 20th to 21st. The autumnal equinox, can't really see it here, sorry, is September 22nd or 23rd. All right, so what you need to do now that you've taken all these notes, is to just sketch this picture. So you've kind of done this before. You did this on your web quest yesterday, but just on the bottom of your paper, underneath of your notes, just sketch this picture quickly and then just label it, please. So September 22nd, 23rd, autumnal equinox or autumn, December 22nd, winter solstice. There you go. All right, so that is it for the notes for now. So what I need you to do is get out of here, and you are going to go to Schoology. If you go to your science class, down to astronomy, Earth and Space and Seasons, the Seasons folder. So you're doing the screencast with the notes and the PowerPoint right now. What you need to do is watch the Edpuzzle seasons and answer the questions, and then there's just a quick video. It's just kind of silly about the seasons being opposite. And then after you finish all that, you need to do a seasons check-in. You do need to get at least 90% on that. You can retake it as many times as you need to, but you do need to get at least a 90% on that to be finished. And I have that listed. I'm going to have that listed for student completion. So you will need to finish that and complete this by the end of the day, or by the end of the week. So if you have any questions, I will be around, but otherwise, happy learning.